Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I'm so excited that you guys are all here. I missed you last week. I hope that you had a great Thanksgiving holiday with your families. I know that we did, and my son, he's 10 months old, and he absolutely loved the Thanksgiving meal, the stuffing, the turkey, the mashed potatoes, the gravy, loved it all. So that was really fun. But I hope that you enjoyed the Thanksgiving break with your family as well. So before we get started, I always like to start with a little introduction question. So I just like to get to know the people that are in the room, and it helps me guide our conversation moving forward. So where are you from? What test are you prepping for? And when you wrap gifts, whether it's for a birthday or a holiday, do you like to wrap them or do you like to stick them in a gift bag with all the tissue paper? I am definitely a wrapped gift kind of person. I love wrapping gifts. I love putting a bow on them. I love getting creative with how to wrap them. And I even will like hand letter a design on the front of it. So I just get super giddy in the holiday season because I absolutely love gift giving and I love wrapping the gifts. I am not a bag person. So if we're doing some sort of like white elephant secret gift exchange, I usually will use a bag because everybody expects me to come with a wrapped gift. So what kind of gift giver are you? Hey, Joseph, it's good to see you. And you do, you know what? If it's like a ball, there's no way it's getting wrapped. So that definitely has to be a gift bag. Unless you find a box to put the ball in. Yeah, I totally understand that. Excuse me. All right. Let's go ahead and get started. Before I do our first problem, here's what I want you to know. This is for you. So because of that, the problems that I'm solving, if you're like, these are not the kind of problems I need to see, I want you to tell me. I want you to be like, hey, I want to see a little bit more geometry next time, or I want to see a little bit more probability next time. I am more than happy to tailor the problems to what you need. In fact, someone earlier this week said, hey, can you do problems on convergent and divergent series? Absolutely. They are not in this week's. They will be in next week's set of problems. But I did see that note, and we are absolutely going to do convergent and divergent because that's what that person was struggling with. So that's what I love to do is tailor the Wednesday night sessions to what you need. Hey, Hope, it's good to see you. Hi, Elena. It's good to see you. You're about to take the test and teach middle school. Fantastic. That's awesome. I love seeing familiar faces. I love seeing new faces in here. So let's get started with the first problem. All right. How many ways can one select 4 colors from a set of 17 unique colors without replacement if the order does not matter? This seems like a really wordy question, but every word in this problem matters. So sometimes in word problems, there's a lot of words and not all the words matter. In this problem, all the words matter because they're asking us how many ways we can select 4 colors from a set of 17 unique colors. I'm going to talk about that word unique in a minute. Without replacement, if the order does not matter. Literally every piece of that problem is important. So, hey, Tom. Hey, Terry. Tom, I did get your email. I wanted you to know that, and I'm going to respond tonight. I didn't get a chance to at work today, but I am going to respond tonight. Just wanted to let you know. I saw your name, and I was like, oh, my goodness. He emailed me. All right, keep moving on. So they're asking us how many ways. So this tells me that I'm doing some sort of like permutation or combination. So I'm immediately thinking, am I using a permutation or am I using a combination? Because I'm looking for how many ways a set can be pulled. It's kind of like probability. And then I know that we're pulling 4 colors from a set of 17 unique colors. That means there's not 17 markers, but like 3 of them are red. All 17 colors are different. Green, yellow, black, brown, blue, purple, lilac, magenta, white, light yellow. Like there's 17. So are we going to use combination or are we going to use permutation? Well, in order to decide that, we have to know what each of those are defined as. Good, Joseph. I like that you responded and you know what we're doing. That always makes me happy when my students know what they're doing. So permutation, order matters. Combination, order does not matter. Permutation, I like to think of permutation as the position. So permutation and position kind of go together because the position of the object matters. So for instance, if we've got 17 kids running a race and I want to know how many ways a kid could be, like the kids could be first, second, and third, order matters because they're in first, they're in second, they're in third. But in this case, I'm pulling 4 colors. It doesn't matter if red or blue or yellow is first. I'm just pulling out 4 colors. So in this case, we are going to be doing combination. Now, without replacement, that means I am not replacing the colors when they go back in. So if the order does not matter and I'm not replacing it, I'm going to use my combination formula, which is n factorial divided by r factorial times n minus r factorial. If I was doing a permutation, then I would be using a totally different formula. I would not be using that formula, okay? So My permutation formula, just for kicks and giggles, would be P equals n factorial divided by n minus r factorial. Okay? So that said, let's go ahead and plug in the information we know. Now, again, I could have this formula memorized all day long. However, if I don't know what the formula means, then it doesn't matter because I can't use the formula appropriately, right? So if I don't know what the N and the R mean, I can't do the formula. So let's talk about what the N and the R mean. The N is the number of things to choose from. The R is the number we are choosing. So in this case, the 17 is going to be the N and the 4 is going to be the R. So let's go ahead and plug that in. C equals 17 factorial divided by 4 factorial times 17 minus 4 factorial. Now, if you have a calculator that can handle this weight of a problem, great. However, most of us do not. What does factorial even mean? So like this problem is really spiraling out of control at this point. Factorial means I'm doing 17 times 16 times 15 times 14 times 13 times 12 times 11. You get the point, all the way down to 1. So I want you to think about this combination formula for a minute. If I'm doing that on the top, and then on the bottom, I have 4 times 3 times 2 times 1 times, what's 17 minus 4? 13. 13 factorial, which is 13 times 12 times 11, and so on. Rather than plugging all of it into my calculator, especially for those of us who don't quite understand the capacity of our calculator, and a lot of times when we just punch in 17 factorial divided by 4 factorial times 17 minus 4 factorial, here's the problem, and here's where I want you to listen. If you are allowed to use a graphing calculator on your exam and you don't tell the calculator like the parentheses and what you want it to do first, it's going to assume an order of operation that you may not want. So if you don't use parentheses in the right places, and a lot of times we have to over parentheses our calculator sometimes, depending on which one we have. If you don't tell your calculator what you want it to do first, you're going to get the wrong answer because the calculator did the wrong order of operations. So I like to simplify as much as I can and then use my calculator, just so that I'm not making an error because of technology. So because this is all multiplication, I can cross off factors that equal 1. Well, 13 divided by 13 is 1. 12 divided by 12 is 1. 11 divided by 11 is 1. And that's just going to keep going until the end of that factorial. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So all of that is going to disappear. So all I'm left with is 17 times 16 times 15 times 14 divided by 4 factorial. 4 times 3 times 2 times 1. Which equals 17 times 16 times 15 times 14 divided by 24. Well, what's 17 times 16 times 15 times 14? Let's go ahead and use our calculator for that. 17 times 16 times 15 times 14 equals 57,120 divided by 24 equals 2,380, which means A is our answer. What is the difference between the order matters and the order doesn't matter? So if I were to pull out the colors And it doesn't matter what order, red, blue, yellow, purple, or it could be yellow, blue, red, purple. Like it really doesn't matter what order I pull the colors out in. But if I were to pull the colors out, an order did matter. And I had to do red, yellow, blue, purple, or blue, purple, red, yellow. That would mean order does matter. Joseph, excellent example. Selecting a president, a vice president, and a secretary. So if we have 500 people, how many different combinations it really would be permutations, would I be able to do if I was selecting a president, a vice president, and a secretary? That would matter because then those people are in that order. So I encourage you, if you still don't understand that could literally be like a 4-hour lesson, really diving into permutations and combinations. Tonight, we're going through a lot of different problems. So I would encourage you to go kind of do a little bit of research on permutations and combinations if that's something that's on your test. This is a 6 through 12 problem. This is not something you're going to see on like the GK or the core. Okay. All right. Problem 2. If 4x minus 6 times 5x plus 3 equals ax squared plus bx minus 18, what is the value of 3a plus 1/2 b? Yes, you can do that on Khan Academy. Absolutely. All right. This looks super complicated, but it's really not. What they're saying is that this value, if I were to simplify it, is going to equal this. Well, what I'm going to do is I'm going to FOIL that out, or I'm going to multiply it out and see if it equals this. Now, there are multiple different ways that I can multiply this out. Some people prefer the distributive property. I'm going to show you that. So if I have 4x minus 6 and 5x plus 3, I can use the distributive property to multiply this. Now, elementary and elementary people, you may not need to know how to solve this problem, but you definitely need to know what the distributive property does, what the commutative property does, and so on. So I'm going to distribute the 4x all the way through. And then I'm also going to distribute the 6 all the way through. So 4x times 5x is 20x squared. 4x times 3 is positive 12x. Now I'm going to multiply the negative 6 all the way through. So negative 6 times 5x is negative 30x. And negative 6 times 3 is negative 18. So when I simplify that, I'm not going to be able to add and subtract everything together. I can only add and subtract like terms. So I'm going to add and subtract my x's, but I can't add and subtract the x squared to anything because there are no other x squareds. And I can't add and subtract the negative 18 because there's no other constants. So 20x squared, 12 minus 30 equals negative 18x minus 18. Now, what do you notice once I've FOILed that? I notice that it matches that. You should know that. You should know that when you see two binomials together like this, it's going to equal a quadratic. In this case, it happens to match this exactly. Ax squared plus bx minus 18. It matches. So now, in order to solve 3a minus 1/2 b, I need to identify my a and my b values. So I need to figure out what a equals and what b equals so I can plug it in to my formula here. Well, what is a in this expression? A is before the x squared, so a is going to be 20. B is going to be negative 18. So I just plug that in and solve. 20, negative 18, 20 times 3, 60, plus. Why did I do a plus? Because a negative times a negative is a positive, and 18 times a half is 9. So this equals 69. Now, this is interesting because I just don't have the right answers because I pulled the problem and then I changed the numbers and then I never changed the answer choices. So our answer is indeed 69. All right. Oh, that's why. Let's see if the right answer still isn't there. But I love that you caught that mistake, Joseph. Okay, every mathematician makes a mistake. Let's go back and erase that. So my mistake was that I didn't catch that this is a plus sign right here. So this should be a plus sign, not a minus sign. So plus a half times negative 18, which means that this is going to be minus 9, which means that our answer is 51, which still means that we don't have the right answer over here. But my answer is 51, not 69. I love when you catch my mistakes because it shows that even I can make mistakes, and I do make mistakes. But the process of figuring that out is extremely helpful for you. All right, let's move on to problem 3. A regular hexagon has a side length of 8 millimeters. What is the area of the hexagon? This is a really, really fun problem. Here's why. Because there's 2 different ways that we can solve this problem. So I can solve it using the actual area formula of a hexagon, or I can solve it using my understanding of triangles. Now, I'm going to be dead honest with you. I do not have the hexagon formula memorized. I know how to find area of a rectangle. I know how to find area of a triangle. I know how to find area of a trapezoid. And my GK people, all of those formulas are on your reference sheet. However, I don't commit formulas to my brain that I don't need to commit to. There's no reason to memorize something that I don't need to memorize. It's just going to cloud up my memory. However, some people love to memorize formulas. It makes them feel more comfortable. So if you're a formula person, I'm going to solve it using the formula first. Then I'm going to solve it the way I would normally solve something like this. So let's go ahead and get started. The area formula for a hexagon. Area of a regular hexagon. Now, a regular hexagon has equal side lengths and equal angles, okay? Keep that in mind. A hexagon could look something like this. 1, 2, 3, 4, 5, 6. That's technically a hexagon. But a regular hexagon is what we're talking about, and that is not equal. But that's the shape we're going for, okay? So let's go ahead and write down the area formula for a hexagon. It equals 3 square roots of 3 divided by 2 times a squared, where a is the length of one side. So in this case, they gave us the side length is 8. So then I can do area equals 3 square roots of 3 divided by 2 times 8 squared. 8 squared is 64, so 3 square roots of 3 divided by 2 times 64. 64 divided by 2 is 32, so 32 times 3 square roots of 3. How come I was able to put the 32 in the front? Because multiplication is commutative. And so I can multiply in any order. And then 32 times 3 is 96. Square roots of 3. Bada bing, bada boom, we're all done. That said, I would not solve that problem that way because I don't have that formula memorized. Now, the way I'm about to solve it is going to take a little bit longer. But that's okay if you're not a formula person. It's still not going to take me over the average of 2.5 minutes that I have per problem on a lot of our exams. So I solved this problem earlier today, and I solved it in the way that I'm about to do, and it took me less than 60 seconds. So let's go ahead and solve this problem using our understanding of triangles. So I'm going to draw the best hexagon I can. Hey, that's a pretty good hexagon if I do say so myself. Thank you, Joseph, for answering that question. That's literally the formula for the area of a hexagon. Someone came up with that formula and we just have to memorize it, or we can solve it this way. Now, if I'm dealing with a regular hexagon, I want you to think about this. I can create a bunch of triangles inside this hexagon, right? I can create a bunch of triangles inside this hexagon. So if I know how to find the area of a triangle, I know how to find the area of a hexagon. Because if I can find the area of this triangle right here, then I can just do area of the triangle, which is 1/2 base times height, and then I can just multiply that times 6, right? Because there's 6 triangles. So easy. So let's zoom in on this. What do we know about this hexagon? The side length is 8, right? However, in order to find the area of a triangle, I need 1/2 base times height. So I need the base and the height. I have the base is 8. I need the height. The height is going to be this length right here. Well, how am I going to find that if this is all the information I have? Here's another thing that we know. We know that this is a 90-degree angle. And we also know, and this is something that you may not know, so this is where you might get stuck. We also know that the angle measurement in a hexagon is 120 degrees. So this entire angle right here equals 120 degrees. And that's something I do have memorized. Why do I have that memorized? I don't know, but I do. So if this line is coming through it in a regular hexagon, it's cutting it in half, which means that this angle is 60 and this angle is 30. How do I know that that angle is 30? Because I have 360 degrees in a circle, right? There's 360 degrees in a circle. And I've cut it into 12 different pieces because I have, if I cut all of these triangles in half, I have 6 triangles that are cut in half, which means I have 12 pieces. So 360 divided by 12 equals 30. Following? Again, I happen to have a lot of this information memorized more so than a formula. Why do I have this information memorized? Because it's helpful information for me to solve a lot of different problems. So I would rather have this memorized than a formula, but a lot of you are not going to feel the same way. I'm showing you both ways because there's a lot of different ways we can solve a problem. So in a 30, now, most of you need to know what a 30, 60, 90 degree triangle relationship is. 90, we're going to call this one 30 and this one 60. Now, I'm going to erase that and redraw that. 90, 30, 60. Now, in a 30, 60, 90 degree triangle, the relationship of the sides is so. X, 2x, x square roots of 3. If you don't have that memorized, you need to understand 30, 60, 90 degree triangles. Now, here's another honest tip. I don't really have that memorized. What I do have memorized is that there is an x, there is a 2x, and there is an x squared root of 3 somewhere in that triangle in a 30, 60, 90 degree triangle. That's what I have memorized. Where it goes, I just conceptually think about every single time I draw the triangle. So angles and sides match up. So when I have an angle, it matches up with a side in length. So the smallest angle is going to get the smallest side. The medium angle is going to get the medium side, and the biggest angle is going to get the biggest side. So in this triangle, the smallest value is going to be x because it's the only one not being multiplied by something. So it's going to go across from the 30-degree angle. Now, is 2 times x or is square root of 3 times x going to be bigger? 2 times x is going to be bigger than x times the square root of 3 because the square root of 4 equals 2, so the square root of 3 is going to be less than 2. All that said, what is the x value going to be? X is going to equal 4 because it's half of 8, which means that my height of my triangle is going to be this one right here, 4 square roots of 3, because I'm going to take my x and plop it into that x square roots of 3. So now I have 4 square roots of 3. Now I can go find the area of my triangle. Area of my triangle equals 1/2 base. Nope, my base is not 4, and that's going to be a mistake that a lot of us make. 8 times the height is 4 square roots of 3. 8 is the base of my triangle because I'm finding the area of this entire triangle. I am not finding the area of this little triangle. That has a base of 4. This triangle has a base of 8. I'm glad I caught that mistake. All right, keep going. 1/2 of 8 is 4 times 4 square roots of 3. 4 times 4 is 16 square roots of 3. That's the area of one triangle. Multiply that times 6, and I'm going to get the area of my hexagon because we have 6 triangles. 16 times 6 is 96 square roots of 3. Would you imagine that? Got the same answer. All right, just to interact with you a little bit, which one would you choose to solve it with? Would you choose number 1 or number 2? I'm just trying to gauge how you guys would solve this problem. Would you solve it using number 1 or would you solve it using number 2? Drop a comment in the comment box and let me know while I'm going on to the next problem. All right, I'm going to move on to problem 4. I'm going to be looking in the comments to see in this room, how would you guys solve it? Joseph, you would use number 2. You and me both thinking alike. Elena, you would use number 1. Tom, you would use number W. I'm assuming that's a typo. Milagros, where did I get the 120 from? That's a tricky question. I can explain that next week. I will go over, I don't want to spend too much more time on this problem. Number 2. So I will explain, I have that memorized, to be quite frank. I know that in a rectangle, the angles equal 90 degrees. I know in a square, the angles equal 90 degrees. And I know in a hexagon, the angles equal 120 degrees. I don't know what they equal in a pentagon. Don't know what they equal in a decagon. I can show you how to do that in a problem next week. There's a formula to find the sum of the angles in a shape. And so I will go over that along with convergent and divergent series. So I'm going to add, I have something in my eye. I'm going to add convergent next week. Sum of angles in a polygon and convergent divergent series. So Milagros, I will go over the formula for finding that in a shape. Thank you, Joseph. Joseph just dropped the formula down in the comments if you're dying to know right now. All right, problem number 4. What is the volume of the figure that would be created from the net shown to the right? This is an interesting question because a lot of us know how to find the volume of a rectangular prism. So if I gave you this shape, and I said find the volume, you would immediately go, oh, I know how to find volume. It's length times width times height. So I would just do 2 times 5 times 6, and that would give me 60, right? Bada bing, bada boom, all done. Absolutely. You're absolutely correct. In this situation, we got lucky. If you didn't know what to do and you just happened to multiply 12 times 7 times 8. 12 times 7 times 8 is 672, and you would be absolutely correct. Now, why would you be absolutely correct? Here's why. Because the volume formula that I actually want you to commit to memory is not length times width times height. The volume formula I want you to commit to memory is area of the base times height. Area of base times the height. Now, in order to be able to solve that formula, you have to understand which shape is the base. A lot of times you'll see prisms drawn like this. A triangular prism will be drawn like this. And people will assume that this is the base right here, this rectangle, because that is what the prism is sitting on. However, that is not the base. The base is actually the triangles. The base in a 3D prism is going to be the shape in which there are 2 identical of. When we name the shape, the base is actually the name. So in this case, this is called a triangular prism. So I know the base is going to be a triangle, but they didn't name this shape for us. They just said the figure. And so I don't know what the base is going to be. Based on that, I have to look at my shape. The base is going to be 2 identical, the base is going to be the 2 identical shapes that we have. So in this case, I have 12 times 8. Where did I get 8 from? I'll tell you in a minute. I have 12 times 7. I have 12 times 8. And I have 12 times 7. And then over here, I have 8 times 7 and 8 times 7. In a rectangular prism, it gets sticky because a lot of times in a rectangular prism, we have 6 rectangles. Partners are identical. So in this case, technically, we could use any of them as the base. However, when we get to triangular prisms, hexagonal prisms, pentagonal prisms, those are where it gets sticky because the rectangles that are going around are not our base. It's the triangle, the pentagon, the hexagon that are our base. So when we find volume, we cannot do just 3 numbers multiplied together. We have to find the area of our base and then multiply it times the height. Here's the other mistake that so many people make. In this shape, if I said that this was 7, most people would say that that's the height, and that's not the height. People think that's the height because that's how tall the shape is, when in fact, the height is actually this number right here. The height in the volume formula is the measurement that connects the two bases together. So in this situation, you would have been correct if you multiplied the 12 times the 8 times the 7. However, if they had a hexagonal or a pentagonal or a triangular prism net shown, that would not be the correct answer. Does all of that make sense? Why 2 times 5 times 6? Again, Joseph, thank you. I was just giving you an example of a volume formula that a lot of people are familiar with. Absolutely, that's exactly what I was doing, Joseph. Yep, I just pulled 2, 5, and 6 right out of thin air and plopped them on the paper. This was just an example. It had nothing to do with the problem. Sometimes I get a little carried away with the teaching side of it because I really want everybody to understand the concepts behind these problems rather than me just getting up here and solving problem after problem after problem. But if you guys would prefer I just go through problem after problem after problem, I'm totally game for that. You just have to tell me, okay? All right, moving on. Simplify. Woo! This is a big order of operations problem. All right, when I see this, I just think order of operations. I can do this. So I am using order of operations for this problem. What is the order of operations? Order of operations is PEMDAS. Please excuse my dear Aunt Sally. So with that said, please excuse is parentheses and exponents. My dear is multiplication and division. Aunt Sally is addition and subtraction. Why did I clump them together like that? I clumped them together like that because they kind of go together. So a common misconception, and I'm sure you guys have all seen this floating around Facebook, where they'll throw a problem up like, I can't even think of one right now. They'll do something like 3 divided by 3 times 2. And they'll say, is the answer 2 or is the answer 1/2? And then there's always a fight on social media about if it's 2 or if it's 1/2. Well, let me just break some news to you. In this situation, the answer would be 2. Why would the answer be 2? Because when I'm doing order of operations and I get to a set of the operations, once I complete the parentheses and exponents and I get to multiplication and division, I'm going to move from left to right. I'm not always going to do multiplication before division. They're kind of married. So once I complete the parentheses and the exponents, so in this case, there's only multiplication and division, I'm going to move from left to right. I am not going to do the multiplication first, even though it's listed first in the order of operations. I'm going to do the division and then the multiplication. Now, if there was addition and subtraction mixed into this problem, then we would have to do all the multiplication and division first, left to right, and then we would do the addition and subtraction. So now that we've cleared that up, let's go ahead and look at our problem. I'm going to look for any sets of parentheses. So I see brackets. Brackets are like the big dogs of parentheses. We're going to solve brackets because brackets usually mean that there's parentheses on the inside. So I'm going to solve this whole chunk first because it's the leftmost parenthesis. Now you're going to notice that when I solve these kinds of problems, I rewrite stuff a bajillion times because I refuse to let a step go. Okay. So 32 divided by negative 16 times 4. Am I going to do the multiplication or the division first? I'm going to do the division first because multiplication and division are married. I'm working within a parenthesis, which means I'm kind of doing an isolated problem. So I'm going to do 32 divided by negative 16 and then multiply by 4. 32 divided by negative 16 is negative 2. Negative 2 times 4 equals 8. So this entire bracket is going to equal 8. So I'm going to write 8, and then I'm going to copy all of this down. Minus negative 8 plus 2 times 9 divided by 3. Now I'm going to look for my next set of parentheses. I see parentheses here, but those parentheses don't matter. Why? Because they're just isolating a negative from another negative. So there's not an operation for me to do within that. So I'm going to keep moving to my next set of parentheses, which is right here, 2 times 9. So I'm going to rewrite everything. 8 minus negative 8 plus 2 times 9 is what? 18 divided by 3. Now what am I going to do? Oh, golly! For the love. I saw you said negative 8, and I thought you meant that I was going to do that negative 8 next. But you are saying that negative 2 times 4 equals negative 8, which means this is a negative 8 and this is a negative 8. Thank you. Yes, you're absolutely right. All right. 18 divided by 3. What is 18 divided by 3? 6. So I'm going to do 18 divided by 3 next because I've solved all of my addition and subtraction. Or I've solved all my multiplication and division. Lordy, I've solved all my parentheses and exponents. I'm moving on to multiplication and division. I don't know where my brain is tonight. I've solved all my parentheses and exponents. So now I'm moving into my multiplication and division that's outside of parentheses, which is why I'm doing 18 divided by 3. Thank you, Terry. You caught my mistake too. I love that you guys are catching my mistakes because apparently my brain is not here. So negative 8 minus negative 8 plus 18 divided by 3 is 6. 18 divided by 3 is 6. Now, what am I going to do next? So here's where it gets a little sticky. Do I do the subtraction? Do I do the addition? Again, I'm going to move from left to right. So I'm going to do the negative 8 minus negative 8. Well, a negative and a negative create a positive. So this is going to become negative 8 plus 8 plus 6. Negative 8 plus 8 is 0. 0 plus 6 equals 6. So 6 is my answer. Now, that said, my lovely people that are in here, Joseph and Terry, both caught my mistake that it would have been a negative 8. If I had kept that as a positive 8, I want to show you what would have happened. If I had kept that as a positive 8 minus negative 8 plus 6, I would have ended up with 8 plus 8 plus 6, which would have been 16 plus 6, which would have given me 22, which is very obviously not an answer choice. So at that point, I'm going to be real honest. At that point, I would have quickly looked to see if I could quickly find my mistake. And if not, I would have flagged this problem and moved on. I'm not going to sit here and labor over this problem unless this is one of the last problems I'm doing, because I've already spent a bunch of time on it. So had I gotten the wrong answer, I would have marked it to come back and I would have moved on. That's just what I would have done to save the time on the rest of the problems, because I certainly don't want to waste a bunch of time on this problem if I've got other problems that I can solve. All right, we have time for maybe one or two more. So let's go ahead and solve this one. This is a long one, so this is going to be the only one we have left. Okay, a gardener wants to create a unique garden for their business. Useless words. Listen to me. We talked about how all of the words in problem number 1 were important, right? In this problem, there's going to be a lot of useless words. So this entire sentence, not necessary. She wants to have a square. Okay, we're getting somewhere. She wants to have a square that has a side length of 6 yards, filled completely with greenery, inscribed inside a circle that has plants planted in the remaining space. I'm going to stop and just imagine what that looks like. She wants to have a square. I'm going to draw this differently. A square filled completely with greenery with a side length of 6. Inscribed inside a circle. So the square is inside of the circle. So now I'm going to draw a circle. And there's going to be plants planted in the remaining space. All the plants use the same type of soil, which costs $6 per square foot. A quarter of the remaining space will have flowers planted at $10 a square yard, and 3/4 of the space will have 1, 2, 3 shrubs planted at $22 per square yard. The greenery will cost $8 per square yard. What is the cost for the soil and all the plants? For the love, that is a long problem. What do we need to do? I'm going to come up with a plan. If I'm solving a problem this long, I need a plan. So my plan, I need to find the area of the circle. Why? Because that's going to tell me how much soil I need. There's no plants on the outside of the circle, right? And I know that all the plants need the same type of soil. So I need the area of the circle times $10 to find times $6 to find the cost of the soil, right? Then I need to find the area of the square times $8. What is that going to give me? The cost of the greenery. How am I going to find the cost of the flowers and the cost of the shrubs? I need to do the area of the circle minus the area of the square. By doing that, if I subtract the square out, I'm only left with these 4 pieces, right? So if I'm only left with those 4 pieces, then I can divide that by 4 and find each little piece, and then multiply it by 10, and then multiply it, and then figure out the shrubs. So let's start with the soil. Actually, let's start with the greenery because we know the side length of the square, right? So the area of the square is going to be 6 times 6, which is 36. Then I'm going to multiply that by $6, and 36 times $6 equals $216. Done. Found the area of the greenery, right? Now I need to find the area of the circle. Area of a circle is a little bit more tricky, okay? Area of a circle equals pi r squared. But I don't know my r. How am I going to find my r? Well, there's my radius. And I know that I just created a 45, 45, 90-degree triangle. If you don't understand how I did that, I will explain that next week because we are not going to finish this problem in enough time. With that said, a 45, 45, 90-degree triangle has x and x square roots of 2, I think. 45, 45, 90 triangle. X, and x square root of 2. Yes, okay. So x, and x square root of 2. So the 6 is across from the 90. So that means 6 equals x square roots of 2. So to find the radius, I have to divide 6 by the square root of 2. So the radius is going to equal 6 divided by the square root of 2. Now, normally I would not leave it like that. However, it doesn't matter because I'm going to round to the nearest cent anyways. So that said, I'm going to do 3.14 times 6 divided by the square root of 2 squared. So 36 divided by the square root of 4, which is 2, and 36 divided by 2 equals 18. So 3.14 times 18 equals 56.52. That is the area of my circle. I'm going to multiply that times 6 to find my soil cost. And that's going to equal $339.12. So I have my soil and I have my greenery. Now I'm going to subtract my circle minus square because I need just the yellow and the blue parts now. So if I subtract out the square, I can find the little pieces of the circle that are left over. So now my area of my circle was 56.52. So 56.52 minus 36 equals 20.52. And then I'm going to divide that by 4 because that's going to give me each little tiny piece. Equals 5.13. Now, with that said, I'm going to multiply that 5.13 times $10 because that's going to be the flour cost. So that's going to give me $51.30. Then I'm going to take the 5.13 and multiply that times 3 because I have 3 little blue sections. And then I'm going to multiply that times 22 because the little blue sections cost $22. And that's going to equal $338.58. So I've got the soil, I've got the flowers, I've got the shrubs, I've got the greenery. I'm going to add all of that together. Oh, Lordy. I just realized that I made a mistake. So I want us to look at this. The soil is $6 per square foot. As I started doing this math in my head, 216 plus 339 plus 338 plus 51, I started realizing that's not going to equal $3,000 or $4,000. That's going to equal not close to that. I needed to convert that square into feet, I needed to convert the 6 into feet to be able to find the cost of that soil. So all that said, we will finish this problem next week because we are out of time. I'm going to turn it over to Dr. A. Here's a little secret. Dr. A is about to give you a code for 35% off your Learning Liaisons courses. But pro tip, we're running a Black Friday deal right now for 50% off of any course. So if you go to our website or go to our Facebook page, you'll see that there's a 50% off code, but I didn't tell you that. All right, we're running a Black Friday deal. Make sure that you check that out. I will finish this problem for us next week. How many questions do I need to ask for a one-on-one tutoring session? Could it just be questions from Learning Liaisons or other questions? You can ask other questions too. We will solve any problems that you want in a one-on-one tutoring. Absolutely. All right, I'm going to turn it over to Dr. A, but pay attention to our social media for a special Black Friday deal. All right, I will see you all next week. If there's anything you want me to solve next week, let me know. I will definitely cover convergent and divergent series, and I will definitely cover angles in a shape.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.